So now we're going into logs. You did a little bit with logs.
Stuco is dismissed to the library. Stuco members, you are dismissed to the library.
So you did a little bit with logs last year. We are going to add to that this year. So same foundation, but we'll just take it a little bit further. Today we're just going to cover the basics. What is a log and how do we graph those? So it should be a fairly short lesson. And then tomorrow when we have everybody back, we'll start getting into like equations and things like that.
Oh, where's everybody at?
It's Stuco. All right, so first you need the definition of a log. So if you have a log of base A, this is what's really important. This tells us how we go back and forth between a log and an exponential. So y is equal to log base A of x. That means a to the y power equals x. In a log, this small number is called the base, just like this is the base of the exponential. So the base of a log and the base of the exponential are the same. A log is like finding an exponent. So when I say log base 2 of, let's say, 8, what that means is 2 to what power equals 8? 3. So sometimes they're really easy to evaluate, sometimes we have more complicated things. So a log is looking for a missing exponent. In these, because in exponentials, the base is always positive, the base of the log is positive. Also, your argument has to be positive. If you take a positive number to a power, you always get a positive. So in a log, the base and the argument are both greater than 0. The only thing that can be negative is what it's equal to. All right, so if I want to first practice going back and forth, if I wanted you to write this as a log, we'd say log, what is the base of this exponential? 1.2. That's the base of the log. That's written as a subscript. So it's a small number there. And then you go across the equal sign. So log base 1.2 of m, so m is my argument, it's a normal size number, and it's always equal to the exponent. So it's equal to 3. Okay, so if I ask you to write this one as a log, it would be log, what's my base? E. Of equals b. It's always equal to your exponent. So you guys, could you write an exponential with a log? Okay. Let's go the other way. If I give you a log, can you tell me the exponential? So on this one, we start with the base. So that's a. What it's equal to is my exponent. So a to the 5th power equals 4. What would we say on b? All right. So that's the first thing on tonight's homework. I'm just going to give you some problems and ask you to go back and forth between logs and exponentials. Are we okay with those? Okay. Let's see if we can practice evaluating these. Now, there's a couple different options. You can set this equal to x and solve an equation. And that would work. If you are confident, you might just be able to look at this and tell me. Because a log gives us an exponent. What this means is 2 to what power equals 16? 4. So if you know that, you can just say it's 4. Okay, if you can't, maybe that isn't as obvious to you. then you can certainly solve an equation. If you set it equal to x, and we use the definition, that means 2 to the x power equals 16. Does this look familiar? We did a whole handout of these, didn't we? How would you rewrite 16? 2 to the 4th. So we get x to be 4. So if you can't look at it and solve it, write an equation and use that. B. 3 to what power equals 27?
3.
And since it's on the bottom, what would we have to do to that? So it's a -3. If you don't see that, do the equation. 3 to the x power equals 1 over 27. Okay, it's the same thing, it's just written in front of you, so we know a negative changes 4, so you get the same answer. Okay, I want you guys to try C and D. See if you can tell me the answers on those. So, some of you are just writing down the answer and some of you are solving equations. It doesn't matter. If you can look at it and tell, that's great. 2 to what power equals 1? 0. If you can't tell that, then set it up. Means 2 to the x is equal to 1. We know 1 is the same as 2 to the 0 power, so we get 0. D, about half the class missed this one, because a lot of you had 5. 5 to what power equals 25? 2. 5 to the second is 25.
She's on.
All right, are those okay? All right. So we're seeing that there's a relationship between exponentials and logs. We can go back and forth between the two really easily. So if I want to look at the graphs, I'm going to go ahead and graph both of these. Y equals 2 to the x. Well, that's kind of annoying. I might have to close my windows. Just to make sure you're not. All right. If we're graphing exponentials, what did I tell you? You always had to plug in.
-1, 0, 1.
-1, 0, and 1. So we'll start by putting all of those in. Okay, 2 to the -1 power would be 2 to the 0, and 2 to the first is 2. So if we plot them, -1, 1/2, 0, 1, and 1, 2. Remember, with exponentials, they always had a horizontal asymptote. This one's at 0, because you'll never do 2 to a power and get 0. What's the domain of that? What's my range? Okay. Let's talk about the log. I said y equals log base 2 of x. And I'm trying to graph that. That's a little bit harder. But let's go ahead and write it in exponential form. That means 2 to the y power equals x. So I'm just graphing an exponential. We know for that we put in 3 points for our exponent, -1, 0, and 1. Which variable is in the exponent? Y. So the y is -1, 0, and 1. So then, if we did 2 to the negative 1 power, we get 1/2. 2 to the 0 is 1. And 2 to the first is 2. So we get 1/2, -1, 1, 0, and 2, 1. What kind of asymptote is this one going to have? It's going to have a vertical. Will you ever get an x value of 0? Will 2 to the power be 0? No. So you noticed the exponential had a horizontal asymptote. The log has a vertical asymptote. What is the domain of this log? And what's our range? Okay, if I look, the domain of the first is equal to the range of the second. The range of the first one became the domain of my second. What are these? What do we call that? Look at my ordered pairs. They were just flipped. What? Yes, these are inverses. So, what we just found out is the log and exponential are inverses. Any questions there? So, last thing we're going to do is just practice graphing some logs. To do this, we're going to do it just how we did the other one. We're going to change it to exponential form and then get our graph. We'll do this one together. So f of x is the same thing as what variable? So if I said y equals log base 1/3 of x. If you change that to exponential form, we get 1/3 to the y power equals x. So 1/3 was given in the problem, it was the base. I'm gonna use those graphs. Okay. So if we make our t-chart, which variable would I plug in -1, 0, and 1 for? The y. Alright, so 1/3 to the -1, 1/3 to the 0, and 1/3 to the first. If I plot those, -1, 0, and 1/3 1. And we know this should have what kind of asymptote? Vertical. So unless you move your graph left to right, your asymptote is just the y-axis. I want you guys to sketch a graph of the second one. Y equals log base 5 of x.
On the same graph or just?
You can do a different one if you want. Everyone got the points. You may have had a little trouble graphing them, but you have the right order pairs. If you change this to exponential, it's 5 to the y power equals x. So put -1, 0, and 1 in for y. 5 to the -1 is 1/5. 5 to the 0 is 1. 5 to the first is 5. 1/5, -1, 1, 0, 5, 1. You should always have a vertical asymptote here. I'm not going to do 5 to a power and get 0, so that y-axis is my vertical asymptote. All right, is that one okay? Right. Then let's do this one. All right. So for these, if I'm going to use transformations, I need a parent function. What's my parent function going to be for both? Log base 3 of x. So your parent function includes the same base, and it's just plain x. So if I'm going to graph that, it tells me 3 to the y is equal to x. We put in -1, 0, and 1. What's 3 to the -1?
130.
3 to the 0. And 3 to the first is 3. We have 1/3 -1, 1, 0, and 3, 1. Parent function is always dashed. What is my transformation here? What does +2 do? Inside is x, does the opposite, so we go left 2. If I move left or right, it's going to move that asymptote with it. I currently have a vertical asymptote at 0, so if I shift left 2, I have to move it to -2. You have to draw in that asymptote. Okay, especially if it's not an x or y axis, I need you to draw that line in to show you recognize we can't go past this line. So then I just move each of my points left 2. What's the domain of that? What's my range? Okay. On B, my parent function is the same. So we have 1/3 -1, 1, 0, and 3, 1. What's the transformation this time? Outside is y, so down. Okay, if I move up or down, is it going to move my vertical asymptote? No, so I still have this vertical asymptote at 0. And then I just move each point down. So it should look like that. What's the domain of that graph? And the range? Any questions there? about 15 minutes, we're going to grade yesterday's homework. So if you don't have that done, you need to finish it. Today, listen carefully here. I posted the section 4.3 homework on Classroom, but it's all the entire section together. So if you look, it was easier for me to make one big file. You're doing day 1 only. So it's like questions 1 through 15, I think. So just make sure you only do day 1. That's everything for the whole section. Don't get overwhelmed there.